viewers, welcome to the video lecture series for the job role of Solanaceous crop cultivator class 10th. In this unit, we have two sessions. First session talks about irrigation and water quality, and the second session deals with the water requirement and irrigation methods, that is, irrigation management in vegetable crops. You must have noticed that vegetable crops require frequent irrigation for better growth and development, but you should know that irrigation requirement may vary from crop to crop. A well-organized water management plan and irrigation scheduling is the key to water management in vegetable crop production. Let us now understand the role water plays in plants one by one. First, it helps in the growth and development of plants. Second, it helps plants to absorb and transport minerals from soil. Third, it is essential for the conduction of biochemical reactions. Fourth, it is integral for making food through photosynthesis. Fifth, it helps plants to manage heat or frost stresses, and it is necessary for seed germination and seedling establishment. Let us now understand the different sources of water for plants. Viewers, rainfall and irrigation are the two main sources of water for plants. Although rainfall is a natural source of water where quality of water is good, but it is limited and unpredictable natural source. Whereas the artificial application of water to soil in order to maintain a proper soil moisture regime for plant growth is called irrigation. There are several factors on which irrigation is dependent. Let us take a look at them one by one. First, the type of vegetable crop. Shallow-rooted crops need light but frequent irrigation as compared to deep-rooted vegetable crops. Second, the growing season. Summer vegetable crops need more frequent irrigation than winter crops. Occasionally, the rainy season crops also need irrigation. Third, the climate crops. They should be irrigated less frequently during cool climate and more frequently in tropical or hot climate. Fourth, the soil type. Frequent but light irrigation should be done in sandy soil, and deep but less frequent irrigation is required in clayey soil. Fifth, the type of irrigation system. Regular irrigation is needed in the drip system and less frequently in the surface, subsurface and sprinkler irrigation system. Let us now discuss session 1, that is irrigation and water quality. In this session, we will learn about these topics. First, importance of irrigation. Second, sources of irrigation. Third, criteria of suitable water for irrigation. Fourth, quality testing instruments. So students, let us begin with the first topic, that is the importance of irrigation. Since vegetable crops contain 80 to 90% water, they require a large amount of water and frequent irrigation for proper growth and development. In water shortage conditions, the yield and quality of vegetable crops suffer. Since vegetable crops grow fast, therefore, they require frequent and more water. Hence, irrigation is essential for their higher yield and good quality. Irrigation reduces dependence on rainfall because it can be done as and when required. If irrigation is scheduled properly, it can save water and minimize weed problems. Irrigation helps in growing more crops in a year in the same field. Let us now discuss the next topic of this session, that is different sources of irrigation water. In this, we shall be discussing surface water sources and groundwater sources. First, surface water sources. Surface water sources are found on the surface of land. These sources are rivers, canals, ponds, lakes, dams, etc. Generally, the quality of water from these sources is quite good and fit for irrigation. Second, groundwater sources. Underground water lifted through dug wells, tube wells and bore wells. This water quality varies from poor to good. Viewers, do you know that India has very few water resources and the groundwater level is also depleting at an alarming rate. Therefore, it is essential to conserve rainwater. The practice of mulching in crops can save water and increase irrigation interval. In some areas, poor quality water full of toxins, heavy metals and microbes is used in the cultivation of vegetables. Ideally, such polluted water should not be used, but if this is the only source of water, then this type of water should be used, but only after proper treatment. Now, let's discuss the next topic of this session, that is criteria of suitable water for irrigation. In this, let us understand the different requisites of suitable water used for irrigation one by one. First, pH. pH of water being used for irrigation should be in the range of 6.5 to 8.5. Second, water salinity. It is an indicator of total dissolved salts present in the water and is of prime concern for both the soil structure and crop yield. Salt concentration is measured by electrical conductivity or EC in millisiemens per meter or micromores per centimeter. Water having EC below 1500 micromores per centimeter is good for irrigation. Third, sodium absorption ratio. It is a measure of the relative proportion of sodium ions to calcium ions and magnesium ions in water. High sodium causes breaking of soil aggregates and sealing of the soil pores. Sodium weakens the binding capacity of soil. A small SAR value indicates low sodium content in water. It should be below 10 in irrigation water. Fourth, residual sodium carbonate and bicarbonate concentration. The residual sodium carbonate and bicarbonate concentration content in water increases the pH. This can have an alkalizing effect and raise the sodium absorption ratio index. Residual sodium carbonate below 1.5 milligrams per liter in irrigation water is considered safe. The following measures can be adopted for the management of this water quality. First, addition of gypsum in low calcium soil plus leaching. Second, addition of sulfur lime plus leaching. Third, more frequent irrigation. Fourth, avoid the sprinkler method of irrigation. Fifth, avoid using fertilizers containing chloride and boron. And last, select tolerant crops. Boron is the most common element found in toxic concentrations in water. It can be easily removed from water. The only remedy is to dilute high boron water. Viewers, the acceptable level of borons is 1 parts per million in irrigation water. Now, let's discuss the last topic of this session, quality testing instruments. It is important to test the suitability of water quality for the intended purpose. Water testing will help to know whether the quality of water is fit for irrigation or not. If it is not, then one needs to find out what is the specific reason for the poor quality of water. Generally, the pH and the electrical conductivity are the two most important parameters for water quality analysis. When a pH color strip is dipped into alkaline or acidic water, the color changes. First, pH meter. pH meter is an equipment by which we can measure the pH level of any solution. It consists of a display unit and an electrode. When the electrode is inserted into the solution, the display unit will show the pH value. Ideally, the pH of the soil and water has to be between 6 to 6.5, and that of the nutrient solution should be between 5.6 and 6.5. For accurate data collection, the pH meter, like all other equipment, should be calibrated beforehand. It is more accurate than the pH color strip. Second instrument is electrical conductivity meter. Electrical conductivity meter is used to measure the total dissolved salts in irrigation water. It is reported in terms of millimoles per centimeter or decisiemens per meter or microsiemens per centimeter or millisiemens per centimeter, which gives us the information on the degree of salinity in water. Microsiemens per centimeter is the standard unit to represent EC value of fresh water measurements. They are all similar on numerical count. Electrical conductivity of irrigation water is more when it contains more soluble salts and vice versa. The temperature of water also affects conductivity, and it is usually reported at 25 degrees centigrade. The EC measurement is the easiest and a rapid method to analyze the salinity level of water, but it is non-specific. It measures only the combined effect of all ions present and cannot distinguish between the type of ions. Summary. So students, let us revise what we have learnt in this video. The important points are importance of irrigation, sources of irrigation water, criteria of suitable water for irrigation, and quality testing instruments. Thank you.